we're now at the stage where we're ready to test and visualize basically our system working, or if it's not working, and spot any problems and try and fix them. So how we're going to test this is we're going to do an OPC communication between the Siemens TIA portal software and Festo's Fluid Sim software. Okay, so I've done a couple of videos of how to do the setup. Here we're just focusing on, coding the system, designing the system, and then seeing it working. Okay, so you can check out the other videos on that if needs be. But if we do want to simulate this, I've got to use the older PLC Sim of Siemens, which is the simulating modules one. So that's for the older S300s PLCs. So let this open up. Just try and get my screen. So there we have it up now. So make sure it's in stop mode because we've got to download the code in. And we've also got to add in, just if you want, actually you don't have to, don't even need to, because we're doing all the simulation through Fluid Sim. So we have that open, and then what we're going to do is we're going to go ahead and download the code in. And because we've got that simulation module open, the TIA portal knows it's going to download it straight into that software package, that kind of virtual PLC. So just give it a wee minute to download. So go on ahead, click everything. Should just really did consistent download, and then there we go. Everything should download nice and easy. And if we want to go online, and we also want to put the system into run mode. Okay, so just put the PLC into run mode. Don't worry about some of the low-level errors. We're all right with that. So if you wanted, you can turn the monitor on and actually see it going through. You can also actually monitor within here if you wanted to, but what we're just going to do is we're just going to visualize it all here because we have the whole setup here. So we also got to turn on Festo's OPC Communication. So I've got to open that up and just make sure that I'm going through. I've got it set up for communication for PLC Sim through to Fluid Sim. Okay, so instead of Code Assist or something else, just make sure that's set up. And then we got to set this up here. So I'll go into my simulation. I'll go into my EC port OPC connections, set up OPC mode, so it's ready for OPC communication. Just got to make sure that some of your settings are right here, so that you're using EZOPC.2 and you're looking in PLC. A is for your output and E is for your inputs. And again, I've done that kind of setup in another video, so I'm not going to worry about it too much. So we press play and it'll communicate across, and what you'll see is A0 is on because the cylinder is retracted, and that should be represented across here. It's not, we're actually due to that little error, but you'll watch the code will, let me just re-download it in. Let me just try it. Put it back into stop, so we download the code in, refresh. We'll continue on ahead anyway and see how we get on. So that sensor's on, that's correct. So what we want to do as well, we want to pretend we've added in a part. So the sensor's on, and then we click start. Okay, so we've got a wee bit of a problem here, just with the communication. Yes, I hadn't put myself back into run mode. So again, part in play, press the start button. Not quite working. Okay, so it's not working now. So a really strange thing. I actually had two versions of the window opened, and that was causing the problem really. But sometimes, you know, these OPC, I've mentioned in other videos, can be a little bit tricky at times. I also solved that problem why I just wasn't getting the full text there. Just before you go to download, make sure you click the full folder of PLC. That was a bit of an amateur mistake, and download it in, and that'll put the full settings into the virtual PLC. But now if we go back here, so pop in part and the sensor, you'll see my motor starts to turn and my piston went in and out. So now essentially what's happening is the part is moved on here and it's being carried along by the motor. So we can see the motor's kept on and we've brought the cylinder back. So what we're going to now simulate is that the inductive sensor will get triggered. So this brings the deflector down for 2 seconds and then turns everything off. So we would imagine that the deflector would come down, this part would fall down, 2 seconds, everything then would shut off. So we'd be able to run that system again by pressing part on, start, it runs, you see the cylinder coming in, coming out, comes along, press the inductive sensor, stays there for 2 seconds, comes back, everything shuts off. Okay. And if we want to simulate the plastic part, we just go ahead and put the part in, click start, moves forward, comes back, so the part is being moved along the carriage, going along nicely. Okay, it's not going to trigger the inductive sensor because it's plastic. It's going to go all the way through and then trigger the optical sensor. So we click that and everything shuts off. And if we want to put another part in, and we just press stop button, everything should turn off and allow us to basically reset the system and start everything back in. Inductive, press the stop, everything goes off. Okay, so a lovely simulation when you get it working in OPC. Just to see the system working. As I said, I have a couple of videos on it. It can be nice when it's working, but there is some issues with the setup between both companies. But hopefully that gives you a full overview of sort of solving this system. Basically, from taking it from the hardware. Okay, we add a little bits on, listing out our inputs and outputs, coming up with a process for pseudocode of how we're going to put it together, how we're going to create these steps and what they're going to mean for us, how to do the wiring diagram to represent the hardware as a wiring diagram, and then essentially how to simulate along with the code. Okay, seeing it all in action and putting it in, creating the steps, using the inputs, all that good stuff throughout the video. So I hope you enjoyed it. Hope you found it interesting. You can see that sensor's now linking across nicely. So if you did do the simulation here, we would see it all working away. Well, I probably wasn't. So we can see all the lines being active and it's in position 20 and it's waiting for us to either trigger one of these lines here. So all really good. Yeah, so it brings us all nicely around, and hopefully I've covered everything. Hopefully you found it interesting and educational. Again, just showing you how to solve these full industrial solutions using a well-tested method that's easy to follow. Once you get into it, keeps your code nice and laid out. If any questions, do send them on to me. And be sure to like the videos and subscribe for more content, more good content. Okay, thank you.